Hello everybody, and welcome to our class video about conditional statements. Our learning goals are that you'll be able to write the converse of a conditional statement, and that you'll be able to prove a conditional statement is false using a counterexample. But before we can really talk about either of those two, you kind of need to know what a conditional statement is. Okay, so a conditional statement is a sentence that's written in a specific form. If this, then that. Okay? So the part after the word if is called the hypothesis. You've probably heard that word in science before, like, if I water the plant more, it will grow more, or something like that. Now, that's probably your whole hypothesis in a science experiment. When we're talking about it in math, the hypothesis is just this part after the word if. The part after the word then is called the conclusion. So if the hypothesis happens, then the conclusion happens. Okay. We abbreviate this as if A, then B, or sometimes just with an arrow, which still means if A, then B, or A leads to B. Alright, so let's look at a few examples. There's two major types. The first is if something happens, then that causes something else to happen. Like this one. If I study well, then I'll earn a higher grade. Okay? Cause and effect there. Alright? This kind of logic we start to learn very early on. Like, take this example. If I throw a tantrum, then mommy will give me what I want. See, that's what the little kid is thinking in his head, even though he may not be thinking those words. But that's the logic. Or, let's take a physics example. If two objects collide, then energy is released in the form of sound. So if we got two cars headed for one another, uh-oh, that's a bad situation, then what do we get? Crash. Okay, don't make fun of my artwork or my sound effects, okay? Alright, so the other type is if something is true, then something else has to be true. Like this biology example, if an animal is a spider, then it has 8 legs. Okay, true statement. A geometry example would be if two angles have measures that add to 90 degrees, then they are complementary. That's the definition of complementary. So if that first part is true, then we can conclude the second part. Or if M bisects segment AB, then, can you finish it? If I know that to be true, then I know segment AM is congruent to segment MB. Okay, so those are our types of conditional statements. Let's talk then about converses. When you write a converse, you're going to switch the hypothesis and the conclusion. Okay, remember that's the first part and the second part, or after if and after then. Alright, so we're going to change if A then B to if B then A. You're just moving the parts of the sentence around. So like, let's take this statement right here. If an animal is a cat, then it is a mammal. Okay, that is a true statement. We're going to switch the two parts. The hypothesis is the part an animal is a cat. The part it is a mammal is the conclusion. So when I switch them, it's going to look like this. If an animal is a mammal, then it is a cat. Okay? Notice that the phrase an animal stayed put because I needed that at the beginning of the sentence to make it still make sense. It wouldn't sound as good to say, if it is a mammal, then an animal is a cat. Like, it just doesn't read as well. Sometimes you have to reword the sentence to make it make sense. Now, some of you are probably thinking already, like, this statement is obviously false. Okay, why is it false? Well, I mean, it could be a dog. Dogs are mammals too. So if an animal is a mammal, it doesn't have to be a cat. That's getting to the second main concept of this video. The dog, in this case, is the counterexample that proves that that statement is false because it could have been a dog instead of a cat. Or it could be a gorilla or a bat or anything else for that matter. Okay? So, what is a counterexample? Counterexample is an example that proves that a statement is false. Think of the counter part of the word as meaning against, kind of like a counterattack. It's going against an attack. You're responding to an attack. Okay, so in order to be a good counterexample, it has to make the hypothesis true, but the conclusion false. In other words, you have to show that the hypothesis that they pose doesn't always lead to that conclusion. It would make sense to have an example of a counterexample again, wouldn't it? Alright, so let's look. So here's our original statement. If a figure is a square, then it has 4 sides. What do you think? Is that true or false? That's true. Every square has 4 sides, so that would be true. If it's a square, we know it has 4 sides. Let's write the converse. Converse is, if a figure has 4 sides, then it is a square. We switch the 2 parts of the sentence again. Is that one true or false? That one is false. Just because it has 4 sides doesn't mean it has to be a square. So, what are some counterexamples? Well, it could be a rectangle, parallelogram, trapezoid, or some other funky quadrilateral that doesn't really have a name, but it still has 4 sides. All of those are counterexamples because the first part is true, the figure has 4 sides, but that doesn't lead to the conclusion that it is a square. That makes all of these good possible counterexamples. Now let me ask you this. Could we have used a triangle as a counterexample? Well, see, a triangle doesn't have 4 sides, so that's not even relevant to the statement. It doesn't even apply. We can't prove that that statement is false because we don't even meet the first criteria. So we have to make the first part true, but the second part false. That's how you can definitively prove that the statement is wrong. Now, you might be wondering, why are we talking about all this? This seems more like English than it does math. Well, in writing these kinds of statements, it helps us classify things, kind of like this Venn diagram. From our previous example, we can conclude that squares are a special type of quadrilateral. So, if it's a square, it has to be a quadrilateral because it's inside that circle. But not all quadrilaterals are squares. This kind of classification is very important for understanding how different concepts relate to each other, both in math and outside of math. Like, you could do a similar thing in science, like frogs are a special type of amphibian. Okay? So, writing these kinds of conditional statements and showing whether they're true or false and looking at their converses helps us see which is a big overarching object and what are special types of it. Alright, we'll do some more practice on similar examples in class. I'll see you guys later.